Hello everyone. Today we will be starting with this chapter lesson 3 of your class 9. That is lesson 3. That is atoms and molecules. So, what is atom and what is molecule? So first we will be discussing with this one. What is atom? So atom is so you studied already this chapter 1 and chapter 2 about matter. So matter is anything that occupies space and have some mass. So if I take this iron nail, so this is a matter. So it's in solid. It's a solid substance. It's in solid state. It's a matter. So it is made up of something. So what is means in this iron nail, what is there? So that one will study. So in not only in iron nails, in every matter or in any substance, something is there. So something is there. So this substance is made up of something. So that one will be dealing in this chapter. So what is atom? So an Indian philosopher was there. His name was Maharshi Kanad. His name was Maharshi Kanad. So what he did, he long ago, around 500 BC, so long back in India. So he was an Indian philosopher and his name was Maharshi Kanad. He postulated that if we divide any matter, consider this iron nail, again I am taking it. So if I divide this one into small piece, at one point of time this division means these things cannot be divided more, means the particles will be so small that we will not be able to divide those small pieces anymore. So he so postulated that Maharshi Kanad said that if we go on dividing a matter, so any matter, so we shall get smaller and smaller particles. If we divide it and keep on dividing the matter or the substance, we will be finding smaller and smaller pieces or smaller particles. So ultimately at one point of time what will happen, that the smallest particles or the smallest piece which we will not be able to divide anymore, so that any more division will not be possible. So he named this particle as Paramanu. So Maharshi Kanad named those particles as Paramanu. So what he gave these particles as named as Paramanu. So what is Paramanu? So Paramanu is nothing but atom, means smallest part of any matter. So if we divide one matter and that at one point that division is not possible anymore, so that last ending, the smallest part, he named them as Paramanu. So after few years, another Indian philosopher, his name was Pakuda Katiyama. So his name was Katiyama. So Pakuda Katiyama. So he means elaborated this Maharshi Kanad's postulation. So he the theory. So he said that these particles normally exist in a combined form, which gives us various forms of matter. And he said that these Paramanus normally exist in combined forms. We do not find these small pieces. They remain in a combined form and they take the form of or take the shape or they take the form of any matter. Means for iron nail or whatever the matter is, that matter is made up of these small particles. So they remain in a combined form. So that one was said by Pakuda Katiyama. So this was all about the history of Paramanu or atom. So so you have probably heard about elements. So you have probably heard about element and compound. So in your previous classes I guess you heard. So what is element and what is compound? So we know that in our nature we have different types of elements are present in our nature, like oxygen, nitrogen, carbon, iron, gold, silver. All these are different types of elements. They are present in our nature. So if they are present in single, so we will consider them, we will call them as element. If only nitrogen, we will call nitrogen as an element. If only oxygen is present, we will call it as an element. So what is compound then? So if two or more elements combine together and take and form something, that one we'll call as compound. So if this carbon is an element, so if carbon combines with oxygen and forms carbon dioxide, then this carbon dioxide we will call as compound. Means here two or more elements formed together and forms this compound. So if only single these elements are present, then we will call this element. If these substances are present in combined form with any of two or more elements, then we will call them as compounds. So by the end of 18th century, scientists recognized the difference between elements and compounds, and they became very interested how and why the elements combine and what happens when the elements or the compounds combine together to form something. So what happens when they combine? So they were very much interested to know these things. So Antoine L. Lavoisier laid the foundation of a chemical science. So chemical science means the branch of science which deals with chemicals only. So his name was Antoine L. Lavoisier. So his name was Antoine L. Lavoisier. So he laid the foundation of chemical science by establishing two very important laws of chemical combination. So he established two very important laws of chemical combinations. So what are these laws? Laws of chemical combinations. Laws of chemical combinations. So what are the laws? So first law was law of conservation of mass. Law of conservation of mass. So this is very important law. You need to remember this law. So it's this law states that mass can neither be. This law states means deals with mass. So this law states that mass can neither be created nor be destroyed in a chemical reaction. So what this law states? The law states that mass can neither be created nor be destroyed in a chemical reaction. Means in a chemical reaction we cannot create any mass or we cannot destroy any mass. So if a chemical reaction takes place, in that chemical reaction the mass should be should be the same. We cannot create any mass or we cannot destroy any mass from that in that chemical reaction. So if we take an example, so consider carbon and oxygen mixed together. So consider carbon is here, so carbon is reacting with oxygen, so it will form carbon dioxide. So in this reaction what happens? So we cannot destroy any mass, or we cannot add or create any kind of mass in this type of chemical reactions. We cannot destroy any mass or we cannot create any mass. So this is all about this law of conservation of mass. This is a very important law. That's the law of conservation of mass. The second one is sorry for the disturbance, law of constant proportions. So these are the two laws. One we already discussed, the second one is law of constant proportions. So in this law what is stated? So this law was stated by Proust. This law was stated by Proust. And what he said, he states that in a chemical substance, the elements are sorry, it's very difficult to handle the phone as well as writing also. Elements are always present in a definite proportions by mass. One second. The law states that in a chemical reaction, in a chemical substance, the elements are always present in a definite proportions by mass. So in a chemical reaction, if we see this chemical reaction, so here this is a chemical reaction. So what happened in chemical reaction? Two elements form together to form a compound. So this was a chemical reaction. So in a chemical substance, so this is a chemical substance. So in a chemical substance, the elements are always present in a definite proportions by mass. So if we take the example of this reaction, this one, H2O2, hydrogen and oxygen mix together, combines together to form H2O, that is water. So water is this the symbol of water, H2O. So when hydrogen gas combines with oxygen gas, it forms this water. So in a chemical substance, if we take this is water as a chemical substance, the elements are always present in a definite proportions by mass. So if we take the water of this earth, or water of any place, of any other planet, or water of this ice, or any water, so water, the chemical formula will always be same. So H2O is the chemical formula of water. The ice, this liquid water, or freezed water, or warm water, so the chemical formula of water is always H2O. So in this H2O, what happens? So if this H2O is 9 gram, consider this mass of this H2O is 9 gram, if you consider. So in this 9 gram, what happens? 8 gram is oxygen and 1 gram is hydrogen. So this is 9 gram. So if you take 9 gram of water, so in this 9 gram, 8 gram will be oxygen and 1 gram will be hydrogen. If you take more, if you add more water, so that proportion will always be same. So 8:1. So oxygen is to hydrogen. So that ratio will always be same. That proportion will always be same. So 8:1. In case of water, this proportion is like that. So for different substances, the ratio will be different. So for ammonia, nitrogen and hydrogen are present in ammonia. So if this is the symbol of ammonia, you take here NH3. NH3 is the symbol of ammonia. So in ammonia, what happens? So nitrogen and hydrogen are always present in the ratio of 14:3. So nitrogen will be 14 and hydrogen will be 3. So this is the ratio of ammonia. So in this ammonia, the chemical substance here, the ratio is like that. Always the ratio will be in ammonia, it will be 14:3. 14 gram if nitrogen, 3 gram will be hydrogen. So in case of water, so 8 gram is oxygen, 1 gram is hydrogen. So this ratio will be for a particular chemical substance, the ratio will always be same. So in what is defined here, in a chemical reaction, in a chemical substance, the elements are always present in a definite proportions by mass. So these are elements, hydrogen, oxygen. So here the amount of hydrogen, that mass of hydrogen, and the amount of oxygen is always constant. So this proportion will always be same by mass. So this is all about this law of constant proportions. So these two laws are very important laws. So you need to remember these two laws for very long. In your higher class also, you will need these two laws. So for this class, I hope that much will be enough. In the next class, we will be going in more detail about atom and other things. So thank you very much for watching the video with so much of patience.